Hello, Namaste. I'm Ek Bahadur Guru. This video is designed to support SCE preparing student of my school. As you know, the government extended the lockdown period up to 3rd Baisakh 2077, and as mentioned in different media, the National Education Board explained that SCE exam will be held 2 weeks later after the termination of lockdown. So the students can use this video as a revision material anytime. The video is related to the first unit, force of science, compulsory science for grade 10. I hope this video will help the student. Let us start our topics. Today we are going to find the change in force of gravitations when the distance is changed but masses are kept constant, and to find the change in force of gravitations when the mass are changed but the distance is kept constant. To find change in force of gravitations between two objects when the distance is doubled, keeping the masses constant. Let us look this problem. To find the change in force of gravitations between two objects when the distance is double, keeping the mass constant. So the condition is we have given force of gravitations, mass and distance between them. Then what change occurred when the distance is double? What change occurred in the force of gravitations when the distance is double and provided that masses are constant. Okay, we solve this in this way. So the solution is, let the two masses be m1 and m2 kept at a distance of d meter. Okay, so if F be force of gravitation between the two objects, then by Newton's law of gravitations, we have F equal to g times m1 m2 by d square. Okay, where g is gravitational constant. So since G is constant, m1, m2 are also constant. Okay, so what we see here, by cross multiplication, G m1 m2 equal to f times d square. Let it be question I. Now we use the main condition. Look at questions again. We have to find the change in force of gravitation between two objects when the distance is doubled. Look at this. Distance is double. Here the distance is double. That is, there is change in the distance. Then what change occurred in the gravitational force or force of gravitations? So to find the gravitational change, gravitational force, so we write the change in distance. Okay, according to question, what we see here, the distance, new distance d1 is double the distance given. Okay, so 2 times d, so double of the previous distance, 2 times d, and we have to find new force of gravitations, F1. Okay, what? So again we use the same law. Gravitation force between two objects is given by Newton's law of gravitations. By Newton's law of gravitations, we have a formula F equal to G times m1 times m2 whole divided by d square. So using same formula, we get for F1 equal to G m1 m2 by d1 square. Okay, so look at here now, or F1 equals, now look at there, G m1 m2 equal to fd square, replacing all this part by fd square, and d1 by 2d, this d1, look at here, twice d, so we get twice d whole square, and this equals f times d square by 2 to the 4 d square. So the common factor d square and d square from numerator and denominator can be cancelled out by 1. So this equals 1 times 4. This equals 1 times 4 f. So what changed? The new force is changed by 1 by 4 times of f. Hence the conclusion is, the force of gravitation is changed by 1 by 4 times of f. Okay, Newton. You can write the unit Newton. So we can find the change in the force of gravitation by this way. Okay, now we go to the next solution, particular solutions. Okay, let's see this problem. Look at this problem. If 2 Newton force of gravitation is produced between two objects when they are separated by a distance of 2 meters, it is given that, okay, they are separated by 2 meters, means the distance between the two objects is 2 meter, and the force of gravitation produced between that two bodies is 2 Newton. Now look at the condition. What amount of force will be produced when they are separated by a distance of 4 meter? Look at this. In these conditions, the distance is changed from 2 meter to 4 meter. Okay. The masses are kept constant, but the distance is changed. So definitely there would be change in force of gravitations. Force of gravitations depends on product of mass and distance between the two masses. Here the masses are kept constant, but the distance is increased. Okay, so we have to find that force of gravitations when the distance is changed from 2 meter to 4 meter. Now we have the solutions as follows. Here let M1 and M2 be masses of two objects, and the distance between them is 2 meter. Then distance between two objects, d equal to 2 meter is given. Again, force of attractions or gravitations, that is F, is equal to 2 Newton. Okay, these two quantities are given. Now from Newton's law of gravitation, F equal to G times M1 times M2 whole divided by square of the distance, d square. So now we put the values given. 2, F equal to 2, G is constant, M1 is also constant, M2 is also constant, and the value of D is 2 square. So on simplification, this gives the constant quantity is G M1 times M2 equal to 2 times 2 to the 4, that is 8. Okay, G M1 M2 equal to 8. So this, let it be I. Now we look at the conditions. The conditions, look at there. The distance is changed to 4 meter from 2 meter. Okay, so what we have here, again we have that the new distance d1 is 4 meter. We have to find new force of gravitations F1 equal to what? Again by Newton's law of gravitations, then by Newton's law of gravitations. F1 equal to g times m1 m2 by d1 whole square. So substituting the values of g m1 into m2 in equation I, we have the value of g m1 m2 equal to 8. So replacing this quantity by 8, we get 8, and d1 is 4 meter. So you can use, since using I, so look at here now, 8 divided by 16, and this equals 0.5 Newton. Hence the required force of gravitation is F1 equal to 0.5 Newton. This is the final answer. Okay, so look at here. One thing you have to consider always, or remember that this distance is changed to 2 meter to 4. Okay, 2 meter to 4. So what happens in numerical problem, the distance can be changed as double, sometimes it changes by treble, or half, or 1/3, 1/3. So what we have to find the new distance, by these conditions. So if it is double, then d1 is twice d. Use this relation. If it is treble, then d1 becomes 3 times d. If it is 1/3, then d1 becomes 1/3 of d. So when the distance is 2 times of d, you can write 2 times d, 2d. If it is treble or 3 times of the distance change, then 3d. And if the distance is 1/3 of the original distance, then we write 1/3 times d. So always using this, we can solve, or we can find the change in gravitational force in this way.